In this video, we're going to go over some select problems from the order of operations, evaluating, and functions review. We're going to start with the order of operations standard. We're going to do number 3 in this video. So number 3 says 10 plus bracket 4 minus quantity 3 plus 1 times 2, close parentheses, minus 2, close bracket, times 2 to the power of 2. So when we're doing order of operations, we use what's called PEMDAS. We write it like this, where it's parentheses, exponents, multiplication, division together, and addition, subtraction together. So this is the order of operations first. So you look to parentheses, then exponent, then multiplication, division, and then addition, subtraction. Okay, so we're looking at this parentheses. We have 2 sets, so you always start from inside to go to the outside. So inside, I have 3 plus 1 times 2. Multiplication comes before addition, M before A. So this is going to turn into 3 plus 2. And I'm going to bring everything else down. Still have this in the parentheses. 3 plus 2 is 5. So this turns into 4 minus 5 minus 2. And I have 2 squared still, and 10 plus here. Still inside the parentheses, we have 4 minus 5 minus 2, so that's going to be negative 1 minus 2, which is negative 3. So in this line, we have 10 plus bracket negative 3, close bracket, times 2 squared. In this order, we have no set of parentheses with multiple operations in them, but we do have an exponent. We gotta take care of this. 2 squared is 4. And then order of operations, we have addition and multiplication. Multiplication we've already talked about. This comes before addition. So you're gonna do negative 3 times 4 first to get negative 12. And then 10 plus negative 12 is going to be negative 2. Okay. So our second standard on this review is looking at parts of an expression, terms, factors, and coefficients. So looking at an expression, just be able to say what are the terms, what are the variables, what are the coefficients, what are factors. So we'll look at number 3, 7d to the 7th plus 8g minus 10p. So terms. Terms are separated by either addition or subtraction. And if we look here, we have 1, 2, 3 terms. So there are 3 total terms. They are 7d to the 7th, 8g, and negative 10p. I would include the negative sign for that one because it is distinguishing it from its positive counterparts here. Variables. These are just essentially the letters that you see. That would be D, G, and P. And coefficients. Coefficients are the factors in front of variables. So when they're in the front, the whole numbers here, sometimes they're whole numbers, sometimes they're integers, sometimes they're decimals, depends. But essentially it's the larger number in front. So it's going to be 7, 8, and negative 10. Okay, so again, terms separated by addition or subtraction. In this case, we have 1, 2, 3. Variables is going to be your letters. And then coefficients are your numbers in front that are being multiplied by those variables. All right, so let's look at an evaluation example. So this standard, you're going to be able to completely evaluate an expression. So this is very similar to the top order of operations are used, except the one extra step is you're going to plug in these numbers for A, B, and C, or these variables. Okay, so we're going to replace all the A's, C's, and B's with the numbers that correspond to them. So for example, negative 1 over A turns to negative 1 over negative 2. C squared turns into negative 10 squared plus 15 divided by B, which is 5, times A, which is negative 2. All right, so Part of it is plugging in. The other part is being able to evaluate from here. So for following order of operations, you're going to focus on this set of parentheses first. Inside here, we have an exponent, we have an addition, division, and multiplication. And out of those things, we have exponent first. So the first thing we're going to do is negative 10 quantity squared, which is going to be 100, plus 15 divided by 5 times negative 2. From here, we have division, multiplication coming before addition. So 15 divided by 5 is going to be first. That's going to be 3. Bring down your 100 plus, bring down your negative 1 over negative 2. Then we have addition and multiplication. We're going to do this first and then the plus 100 second. So 3 times negative 2 is going to be negative 6. I'm going to change negative 1 over negative 2 to 1 over 2. The negative signs cancel out. So you're going to have 100 minus 6. And now I have parentheses, multiplication. So parentheses still have one more operation to do. So it's going to be 1/2 times 94 when you subtract 6 from 100. And half of 94 is going to be 47 as your final answer. So this is really not a whole lot different from the order of operation example, except the only first step that's different. The only step that's different is the first step where you have to plug in these 3 numbers for A, B, and C. Going on to the back, the standard where we talk about functions and relations. Functions are different than relations. Functions are a special type of relation. All functions are relations, but not all relations are functions. So for example, a function is special because every x has a unique y value. Okay, so an x value cannot go to or map to 2 different y values. Every x value can only map to one y value. Now, 2 different x values can map to the same y value. That's okay. It's just the other way around can't work that way. So every x value maps to only one y value. And that makes or breaks it. Okay. So let's look at this first one. Inputs and outputs, or we call them x's and y's. Doesn't really matter which way you call them. 4 maps to only one number. Okay, so we're good there. 7 maps to 3. It also maps to 8. That is not okay. So because 7 goes to 3 and 7 goes to 8, this is a relation, not a function. All right, the second example. Look at the x values, or the inputs. Input 1 goes to output 2. 5 goes to 9. 8 goes to 6. All 3 inputs only have one output each, so therefore this is a function. If we were to adjust this and say, let's say instead of 1 to 2, I made this 1 to 6. You might look at that and say, well, that's no longer a function because 6 has 2 x's going to that. But it does not break our rule here. Every x value maps to only one y value. It says nothing about a y value having more than one x value mapping to it. This is still okay. If 1 were to map to 6, we'll cover up 2 here, that would still be a function. Number 3, we have a graph here. Okay. Now the graphs we can use the same concept. Every x value only has one y value. And how we use that is we use what's called a vertical line test. So if you draw a vertical line anywhere on a graph, and if it hits more than once, it is not a function. So if I draw a vertical line anywhere, there. Hits once, hits twice. So essentially what you're saying here is that this x value right here, it maps to this y value and to this y value, which, as we already said, is not okay. Every x value has to have only one y value. So when you make this vertical line hit in 2 spots, you're essentially proving that this is not a function, but rather just a relation. All right, the last example on the review we're going to look at is number 2 for evaluating functions. This is very similar to the evaluating an expression with variables, but in this case you only have one variable, it's x. So function notation, when you see that does not mean f times x, that means f of x. Okay, so function of x, which is also essentially what you've known as y so far. So this says evaluate f of x for equals 20 plus 4x squared for f of negative 2. So that means that every time you see an x, you're going to replace it with a negative 2. And I see that in one spot here. So f of negative 2 is going to be 20 plus 4 times negative 2 squared. So the only x I saw here was 4x squared. I replaced that x with negative 2. Now I'm going to utilize my order of operations. I have addition, multiplication, and an exponent. And I know that exponents come first, so I'm first going to do negative 2 squared, which ends up being positive 4. Remember, it's negative 2 times negative 2 because it's a parentheses are around the negative 2. Now I have addition and multiplication. 4 times 4 comes first, so 20 plus 16, which ends up being 36. So f of negative 2 is equal to 36.